Hello everyone. In this video, I would like to talk about the program of predict rectangle using support vector machine. How to implement support vector machine using Python. First, we want to specify 2 point to class of data. Support vector machine is supposed to predict the value greater than 1 for positive scale and values lower than -1 for negative scale, which constraint W is small as possible. Then we can compile to condition now about to central optimization program. We minimize the value W with subject to discretization is sacrificed, where we use the SCN either side function. This is the cost function of the support vector machine, where lambda is scaling parameter and theta is model parameter. Then to update parameter, we should remove the max function by this equation. The change will be this function if the condition the restriction is lower than 1 and otherwise. Then we can calculate the derivative of change with respect to theta and the derivative of the loss function change respect to the bias term. Then we can use gradient descent to find the optimal parameter B and bias term. The theta nu k plus 1 equal to k theta k minus 2 London rate multiplied with the derivative of change respect to theta. And the same with the bias term. We update bias term, the new bias term by subtract the old value bias term by London rate and multiply with the derivative of change respect to bias term. To implement the SVM, we use the conduct of update parameter function, which iterate to update the parameter. In each iteration, we will calculate the gradient according to the reverse equation and update it. The calculate gradient, we use the multiply function, which is convenient of NumPy library to calculate the gradient of theta, and also the fixed function will call the init parameter and update parameter, and the fixed function will return the theta and bias term. Oh, and we also conduct the loss function to return the loss value over the training set, and the redirect function to redirect the class over the unseen data. The rectangle dataset, we now using the model our custom model to predict the breast cancer. Let's talk about the breast cancer dataset. Example, in this dataset, we have 12 attributes. The first one is the ID number of people, and the second column is the status, malignant or benign, and other 10 relevant features are confused from X cell nucleo. We use the Stansted scaler to scale the dataset with assign malignant level to 1 and benign to -1. The learning curve of the training iteration. We trained the model over 100 iterations with learning rate equal to 0.01. We can see here the loss value decrease and the accuracy in recently. I evaluate the model performance using the translate split strategy with the test set is 20%. After testing, the model accuracy is 90%. Thank you so much. Hope to see you in the next video.